chemical reactions and equations. Think what happens when milk is left at room temperature during summers, or iron nail is exposed to humid atmosphere. So, in all the above situations, the nature and the identity of initial substance have somewhat changed. The nature and this identity of the initial substance have changed. Now, in previous classes, you must have studied about the physical and the chemical changes. So, in the above situations, as chemical changes has taken place, we can say that chemical reaction has taken. Now, you may wonder that what is a chemical reaction? How we know that a chemical reaction has taken place? To find the answers of these questions, we have to perform some experiments, and you know that chemistry is incomplete without experiments. Let us begin with experiments. Activity 1. Take a piece of magnesium ribbon nearly 2 cm long. Clean the surface with a sandpaper, as there is a deposition of magnesium carbonate, and that's why we should clean with sandpaper. Now hold the ribbon. Step 3. Hold the ribbon with a pair of tongs and burn it in air, either on a spirit lamp or burner. Now step 4. Collect the ash formed in a watch glass. Observations you will see on this experiment. Ribbon burns with dazzling white flame. Energy in the form of heat and light was emitted. A white powder is formed, which has been collected in the china dish. So what are the conclusions? On examination, the white powder is magnesium oxide and has been formed by the combination between magnesium and oxygen, which is a constituent of air and supports combustion. Activity 2, the step 1, we will do in 2 separate glass beakers. We have to take 2 separate glass beakers and dissolve small amount of lead nitrate and potassium iodide in water. Step 2, add potassium iodide solution to the lead nitrate solution. Observations: a yellow precipitate or PPT is formed at the bottom of the flask. We will see a yellow PPT is formed. It is formed because it is insoluble in water. It is not soluble in water, it is insoluble in water. Now, what are the conclusions of these experiments? On analysis, it is found to be lead iodide, and it does not dissolve. That's why I've said that it does not dissolve, and therefore it separates as a PPT or precipitate. Next activity, third activity we have to perform. So we have to take few zinc granules in a test tube or a conical flask. Now we will add some dilute hydrochloric acid. We have to add dilute, not concentrate. We have to add dilute hydrochloric acid or sulfuric acid to this. Observations, we will get bubbles of a gas. Bubbles, we will see bubbles of gas evolve accompanied, these are evolved by brisk effervescence. Second, we get on analysis the gas evolved as hydrogen, that we have to check that it is hydrogen or carbon dioxide or which gas is heated, that is checked by different methods that we see on later videos. Upon touching, the flask is heated. Now, so for that, these observations are observed, and upon these observations, now we can say the conclusions. Now the gas evolved is hydrogen, and the solution left is colorless. We will see colorless solution. So temperature is also, as we see that the flask is heated up, so we can say that temperature is changed and heat is evolved. That is known as exothermic reactions. Now the last thing, we come from these observations on the above activities, we can say these observations are of these following experiments helps to determine whether a chemical reaction has taken place or not. If you want to know that a chemical reaction has taken place, we have to know four things, four observations. Now what are that? That four are: number one, the change, there should be a change in state. Change in state first. Second is change in color. Third, evolution of a gas. Fourth, change in temperature. If this any of the four changes has taken place, then we can say that a chemical reaction has taken place. So this is the video of the chemical reactions, basic chemical reactions and equations.